Hi guys. So this is section 3.1 and this video is to help you better understand how to go through problems 4 and 5 and if we have time 6 from the reading for section 3.2, correction, section 3.2. In class, it always feels a bit rushed and I want to have enough time to go over this slowly and carefully and make sure that you understand it. So as you can see on your screen, this is example 4. Okay, and this is for when you have to tackle a word problem that requires you to find the formula for an exponential function, but you are not necessarily given an initial value or one that is obvious, or you are not given a rate that you can get your factor from. Instead, you are given 2 points that exist on that particular exponential function, and you have to use those points to be able to derive your function formula, and then using that function formula, be able to answer the questions being asked. So in example 4, as you may recall, they give you 2 points. They give you the point in 2002, 80 deer were reintroduced. So you know that that's the first point you're given. We're going to label that point. And let's fix that screen there for a minute. There we go. We're going to label that point 1. All right. That you were given, and we'll make that our little given list. This is point 1, and you're told 2002, and you know, as you always know, time is always by default. If that's one of your variables, it is your input variable. We have 2002 and 80 deer. Okay, so we know that this is time in years, and this is deer population. Now, as we keep reading, it says, we are reintroduced into a wildlife refuge area from which the population had previously been hunted to elimination. So that means that previously, because they were hunted to elimination, there were no deer, 0 deer lived there, and this is when they were reintroduced. So because we know that prior to this, 0 deer lived there, we can then assume that this point we are being given is indeed our initial value, or for the purposes of our function, this is A. Okay? We keep reading to see if we're given a rate or a factor. It says by 2008, the population had grown to 180 deer. So there's our second point, 2008, 180 deer. So 2008, 180 deer. This is our point number 2, okay? And then we're being asked to find if the population continues to grow exponentially. They want us to find the formula, and here's the important part, f of t, which is going to give the number of deer at t years. So we have been told that our function is going to be f of t, which gives us the number of deer, and that our input variable is t, which is in years. Now we can add to this the caveat that this is years from 2002, since we have established that this point here must be our initial value A, since prior to this point there were no deer there. So this is where we're starting to count our population. So that being the case, we now know that this is A, but what we don't have, okay, this is what we were given. What we don't have, or is not given, okay, is we don't have a rate, and we don't have B, which is our factor. Okay, so obviously we have to be able to find one of these. And the method that we chose to find one of these is we used what we already did have to at least start writing our formula and then go from there. So the first thing we could do is, using our initial value, we can write our function as f of t equals A, which we know is 80, right, from over here, 80. We don't know what b is, but we know it's being raised to the power of t because that is our input. So that's as far as we are so far. Now what we can do is then take the other point we were given, point number 2, and use that to substitute into what we have so far and therefore then be able to find b. So we're going to take our second point and we're going to do our second step, which is to take it and sub it into our equation, f of, this time t has to equal the number of years from 2002. So you can do a little aside over here and be like, okay, 2008 minus 2002 gives us 6. So that is the t that this equals. This equals year 0 because that's when we started. And this equals year 6. Okay? So we're going to sub it in, and this is going to be f of t equals 80. We still don't know what b is in year 6, but because we know what our output was in year 6, we know our output was 180. We can now sub further and say, well, it was 180 in year 6 when we started at 80, our initial value, and multiplied by some factor b, which we do not know, and we raise it to the power of 6. So now we have everything but b, so we can go ahead and proceed to solve for b. So that's what we're going to do. We are first going to get rid of the 80 on one side. And whatever you do on one side, you do to the other. So that divides out. And this becomes 180 over 80 equals b to the 6th. Now, it behooves us, since we're going to work with this in fractional form, it behooves us to simplify this. And this simplifies, if you get the greatest common denominator, it simplifies down to 9 over 4. So 9 over 4 equals b to the 6th. Now we're ready to move on to step 3. Okay? And step 3, we take this equation that we've now just discovered right here, and we're going to say, all right, so 9/4, we're going to rearrange it a little bit so that we can place it into Excel. 9/4 equals b to the 6th. We know that to get to b, just like if we recall, okay, and I'm going to put this over here for you. If you recall, if I have x squared equals 25 and I want to know what x equals, I take the square root of x squared and I take the square root of 25, and the square root and the power of 2 cancel each other out, leaving me with just x equals, and the square root of 25 is 5. Okay, so if you recall that that's how that works, then what would cancel out to the power of 6? It would be the sixth root. And we do that to both sides. Now here, the sixth root cancels the power of 6, leaving us with just b. And here we have the sixth root of 9/4. But that's not how we're going to put that into Excel. Into Excel, we need this to be an exponential notation. And if you recall from section 3.1, we found out that if we have something under a radical that is being raised to a particular root, we can rewrite it in exponential notation by saying, okay, let's take our base, which in this case is 9/4. We're going to go ahead and take our base, 9/4, and it is being raised to the power of, if nothing's there, it's automatically the power of 1, and that becomes our numerator in our fractional exponent. Over our denominator is the root we're looking for, which is the sixth root. So that is another way to say what is equal to b. And this right here, we can very easily take it and write it in Excel. If we put that into Excel, you would type it into your cell like this. You would type in equals, and you would say parentheses 9 divided by 4. That quantity, which is why we close the parentheses, is being raised to, using the caret symbol, the power of, and because our exponent is also a fraction, we're going to use parentheses again. Parentheses 1 divided by 6, close the parentheses, since that tells Excel that the entire fraction or division problem is your power. And when you hit enter, Excel tells you that this is equal to approximately 1.44714243. And that is basically what B is equal to. So we're going to say that B approximately equals, and we're going to round it to 4 places, 0.4471. And now we have a B. So now we can finally complete our problem, which was to find the formula and write our answer as f of t equals A, which was 80, times B, 1.4471 to the power of t. And this would be the answer that you would put into Lumen as your answer for this question. All right, and this is our answer. Now, we're going to move on to number 5, and this time you're going to see that we're going to solve it similarly to what we just did here in number 4, and that is why in class I referred to as the process that we did as being similar to method 1. But this time I am going to go through it very carefully, both method 1 and 2, to make sure that you understand it clearly and can therefore do the homework. The one thing I did add in class, and I want to add that here, is that this rate over here that we came up with, should you be at this factor that we came up with, if you were asked to then interpret at what rate the population of deer was growing, you would turn that rate, that factor, into a rate by recalling that B equals rate plus 1. So if that's the case, then you could say 1.4471 equals R plus 1. And then now we're going to solve for R, which is the rate. So we're going to subtract 1 from both sides. Okay, and when that happens, you're left with approximately 0.4471 equals R. That's the rate in decimal form. You then turn it into a percentage by simply moving over your decimal 2 places to the right. And so this is approximately 44.71%. And since it's positive, this is growth rate of deer population. And now that you have this growth rate, you could also use that to statistically predict approximately how many deer you might have at any other point in time, as well as you could use the equation that you came up with to predict how many deer you might have in any given year. Okay? So, but this part right here was an extra aside that we did in class just because it's good for you to see the relationship so that you can see how you would interpret those two things together. Okay? All right, let's move on to example number 5, okay? In example number 5, you are given the following information. You are told to go ahead and find the exponential function f of x, and the only information you're given is that it goes through these 2 points. Here's point 1, and here's point 2. Okay? Clearly, just by looking at the points, we know that no A has been given to us because A, as you know, is our y-intercept and would have to be in the form of some 0 value of the input to some B or Y value of the output. so that since neither of our points is in this form, we know that we have no A. So we are not given an A. We are also not given B. We don't know what our factor is, okay? We're not giving a rate, so we're not given a rate of any kind. So we don't know whether this rate is, we also don't know whether this rate is positive or negative. So we don't know whether this is growth or decay. These are all the things we don't know. But we do not have to feel overwhelmed by what we don't know because we can use what we do know, okay? Here's how you can use it in method number 1, okay? So in method number 1, if they ask you to find the function, we start by running the standard function. The standard function, okay, is f of x equals a times b to the x, right? And step 1 is that you're going to sub the first point into this equation, okay? So sub first point. Our first point is negative 2, 6. So we're going to go ahead and sub that in, okay? We're going to sub f of x equals, we don't know what a is, we don't know what b is, but we do know that x here is a negative 2. And we know that our output, or f of x, is 6. So that means that this is going to be 6 equals a times b to the negative 2. All right? That's step 1. Step 2 is to solve for a from the above equation that we just wrote, this one here. So we're going to go ahead and solve for a, okay? So 6 equals a times b to the negative 2. If we want to solve for a, we have to divide by b to the negative 2 on both sides. B to the negative 2. That cancels. And now we have a equals 6 over b to the negative 2. Okay? Now, we're going to hold on to this for a minute. So we're just going to set that aside. All right? We're going to go ahead and highlight that. We're going to set this one aside because that's what we got for a using point 1. And now we're going to move on to step 3. Okay? And step 3 is to sub the second point into our general equation. So again, point 3 here means that now we're going to go f of x equals a times b for step 3 rather. The second point, and we're going to go ahead and highlight this in orange right here. Here's our second point. We tells us that our x is 1. So this is raised to the power of 1. And it also tells us that our f of x, or our output, is equal to 2. So we're going to write this as 2 equals a times b to the 1. Okay? Now what we know is that now we're going to repeat step 2, or we can call it step 4, where we're going to solve for a again. But this time we're solving for a from this equation that we just came up with. So we're going to go ahead and solve for it. And that means that 2 equals a times b to the 1. Okay. And since 2 equals b to the 1. Oh, no, wait, I'm sorry. My mistake. I'm probably confusing you guys right now because I read that point wrong. Let's fix that. The point here tells us that our output is 1. So it's 1 f of x equals a times b raised to the x power, which is 2. And our output is 1. So that this becomes 1 equals a times b squared. There you go. That's what we're going to solve. That makes a lot more sense. My apologies. All right, so now we're going to go ahead and take that and solve for a again. So we have 1 equals a times b to the second power. We're going to go ahead and divide by that b to the second power on both sides so that we can solve for a. That crosses out, and now we have a equals 1 over b squared. That's the second one that we came up with. All right, and we'll highlight this one in orange. So now we have an A equation for point 1, an A equation for point 2, and now we're going to ready to move on to step 5, where we're going to go ahead and set them equal to each other. Set both A values equal to each other. In essence, we're setting up a proportion. Okay? So we're going to say, all right, well, in that case, we have 6 over b to the negative 2 is equal to 1 over b squared. Okay? And now we need to, since we want to solve for b, we're going to need to get all our numbers on one side and all of our variables on the other. And we want to solve for b, so we want to get our b's all on one side and leave our numbers on the other. So the easiest way that I can see to do this is this one, we would have to multiply by b to the negative 2, because as you know, in essence, that's a fraction, and you have to, when you divide by a fraction, you're multiplying by its reciprocal. So this is 1 over, in essence, if we leave the 6, this is 1 over b to the negative 2. So we're multiplied by the reciprocal, which is b to the negative 2 over 1. And whatever we do on one side, we have to do to the other, okay? Now on this side, they cancel and they leave a 6 by itself. On this side, b to the negative 2 times over 1 times 1 over b squared becomes b to the negative 2 over b squared. And let me fix that b there. That keeps looking like a 6. There we go. Now, this here allows us to use the quotient rule. And the quotient rule says that if we have the same base, which we do, it's b, we subtract the power. So this is really 6 equals b to the negative 2 minus 2, okay? And that is 6 equals b to the negative 2 minus 2 is negative 4, okay? So now if we want to solve for b, because so far we still have it as an exponent, if we want to solve for b, we want to then do what we've done before to get to b by itself. If it's going to the negative 4th root, the negative 4th power, to get rid of that, we need to get the negative 4th root. So if we take the negative 4th root like this, then we have to do it to the other side as well, the negative 4th root. So that means that this now is just b, and it equals 6 to the negative under the radical of the negative 4th root. Now this here, we have to rewrite it in our exponential notation. So the way that we can do our exponential notation is that we remember that we take our base, which is 6, to the raised to the power that it's being raised to. It's currently being raised to the first power, so we're going to raise it to the first power, and that becomes our numerator over the fact the denominator becomes whatever 4th root it was being raised to. It's being raised to the negative 4th root. That becomes our denominator. And that means that 6 to the 1 over negative 4 equals b. And this we can write in Excel by typing equals, and we're going to say parentheses, well, we don't have to put the parentheses, we just say 6 raised to, and now we need our parentheses, then 1 divided by negative 4. And when you do that and you hit enter, the answer that you get is approximately b is equal to approximately 0.6389431 0, 4. So there's our B. Once you have found your B, now you can move on to step 6, which is find A by subbing B into function form. So we're going to go ahead and take f of x equals, we now have a B, right? We need to know our A. So A times our B, we're going to take it to 4 points out past the decimal. So 0.6389 raised to the x power, right? This is how far we've gotten in step 6. Now in step 6, once we do that, we're going to pick a point, okay? It doesn't matter which one. We were given 2. They both live on the same exponential equation. So we're going to pick a point and sub it in so we can solve for A. I'm going to go up here and I think I'm going to pick my positive point, which is in orange, and that's 2, 1. So that's the point I'm going to pick. I'm going to pick point 2, 1, and I'm going to sub it in. So that becomes that this is my output, right? And this is my input, or my x and y, however you want to look at it. So I'm going to go ahead and put those in. I'm going to say, all right, well, my output is 1 equals A times the B that I finally found, 0.6389, raised to the square power, because that's my input. Now I can solve for A. So that means I have to divide by 0.6389 squared, and I have to do it on both sides by 0.6389 squared. That cancels, and A is equal to 1 over 0.6389 squared, okay? Which, if we put into Excel or even into your calculator, all right, if you take it in its squared, it means that A is approximately, because we're rounding off now several places, it's approximately 2.4494, okay? And if you wanted to know, or if you're curious, this squared, which you can put into a regular function calculator, comes out to approximately 0.40824829. Okay, and then obviously you divided 1 divided by that. And that's how you found out what it was. That's when you find out what A is. So you know that now this is A right here. All right, and we'll highlight that in blue. So now we're finally able to give our answer, and our answer, okay, is that f of x equals A, which is 2.4494, times B, which is 0.6389 to the x power. There is our answer of the function equation. Now, that was method 1. And as you can see, method 1 can be rather lengthy. It has 6 full steps. Method 2, as we did in class, has fewer steps in the beginning, but we still have to do step 6 the same, which is to take the B we find and sub it in to get the A. So here's the answer we got using method 1. We're going to leave that there. We're going to highlight that in red. And now we're going to do method 2 right next to it over here and see if you can find the way it is easier to accomplish it, okay? So method 2 goes like this. Okay, as you saw in class, I'm just going to repeat it now so it's nice and clear. This is going to be method 2. All right. So once again, we're tasked with finding the function for these 2 points. As a reminder, we were given the points -2, 6, and we were also given the points 2, 1. Now, what I like about method 2 is that a lot of the work is just having some simple logical thinking skills. We recall, and I put this in your notes already, we recall that the way exponential functions work is that every time the input, or the x, goes up by 1 unit, the output, or the y, is being multiplied by the factor, or the b, okay? And so that allows us to do the following steps of reasoning, okay? So, step 1. If I look at my x's, when my x's went between the 2 points that I have, my x's went from -2 all the way to +2. And if I think about that along the x-axis, that means I did -2, -1, 0, 1, 2. That's 4 units. So my x's increased by 4 units between the 2 points that I have. Okay? So if my x's went up by 4 units, that means that every single time that happened, my y got multiplied by b. So that means that the first time that happened, I had y times the b. And then it happened again, and it was y times the b again. And then it happened again, and y was multiplied by the b again. And one more time, y was multiplied by the b again. Well, obviously, I can rewrite this as y being multiplied by the b 1, 2, 3, 4 times. So b to the 4th power. Okay? So once I have reasoned this out, this is the important part for step 1. I have reasoned out that my y got multiplied by b to the 4th power. I am ready now to move on. Okay? Because in step 2 of the second method, all right, since that's the case, now all I have to do in step 2, again, a little bit more reasoning. I have to think to myself, all right, well, y in my first point started at 6. That's where y started. And y in my second point ended at 1. Okay? So if that's true, I can reason the following. That my first y, which was 6, times this b to the 4th, which I know had to have happened since my x went up 4 units, has to equal my second y, which was 1. Okay? That's what I do in step 2. And once I have found this equation in step 2, which I'm now going to highlight in orange, now I'm ready to move on to step 3. In step 3, I have to solve for b. Okay? So I take this equation that I came up with, 6 times b to the 4th equals 1, and I solve for b. Well, that means that the first thing I have to do is divide by 6 on both sides. That cancels, and it leaves me b to the 4th equals 1/6. Then, because I want to get to the b, I'm going to obviously have to do the opposite of exponents, which is radicals. So I'm going to go ahead and take the 4th root radical of both sides. So what you do on one side, you must do to the other, right? And that will cancel out my exponent, leaving me just b, because that cancels that, and that equals the 4th root of 1/6. Now, I can't enter this into Excel in this form, right? But I can if I change to exponential form, so to expo form. So that's what I'm going to do. Remember that to do that, you just simply take whatever's under the radical, so b equals whatever's under the radical, which is 1/6. I raise it to whatever power it's being raised to under the radical, and that becomes my numerator, so that's 1, over whatever root I'm looking for, which is the 4th root, that becomes my denominator, 4th root, which I can enter into Excel as equals, parentheses, 1 divided by 6, or 1/6, that quantity being raised to the power of, parentheses, because I have a fractional exponent, 1 divided by 4, close the parentheses, hit enter, And Excel tells me that B is approximately equal to 0.638943104. Okay? Now, if we look at that B, I'm going to pause there for a second. We're going to highlight the B that we found in green. And I want to go back to our original method and see, what did we get for B? There it is. Look at that. Same number. So that tells us we are most definitely on the right track. Now we take this B, okay, and it only took a step, 3 steps to get here. Now we take this B and we put it back into our equation for step 4. I hate when that happens. We're going to sub into expon form. All right. So that means that we're going to go, all right, f of x equals a times b to the power of x. So f of x equals a, which we don't know, times b that we just found out, 0.63. And we're going to take it 4 places out, 8, 9 to the power of x. And now we're going to pick one of our points, sub it in, just like we did in step 6 of the previous method. You're going to pick a point. And once again, I'm going to go ahead and stick with the point we picked earlier, which was the point 2, 1, which is our second point that we had highlighted in orange. I'm going to go ahead and do that same point just to keep things consistent. So we're going to go ahead and sub that in. So that means that f of x equals a, which we don't know, times 0.6389 that we just found out, to the x, which in this case is a 2, so to the 2, and f of x is my y, so that means that I can sub this as a 1, so 1 equals a times 0.6389 squared. And look at that, we divide by this to solve for a. We're going to go ahead and divide by the 0.6389 squared on both sides. And on this side, it cancels, and it leaves us a equals 1 over 0.6389 squared, which once again, I'm going to highlight this in yellow. And if you go back and look at our step 6 on our previous method, look at that. We came to the exact same conclusion there. So again, you can put this into Excel or you can put it into a calculator, and it's going to tell you that A is equal approximately to 2.4495. There's that same A, which we can now take, and for the answer, write our formula, which is what we were looking for, and that was f of x equals our A, which is 2.4495, times our B, which is 0.6389, approximately, we're rounding off, the power of x. There's the equation we came up with. We're going to highlight that in red. And let's see if that is the same as our previous equation. And sure enough, if we go back, where is our previous equation? There it is, right there. If we go back here and we look, there is method 1 equation, and it is 2.4494 times 0.6389 to the power of x. And here is our method 2 equation, and it is exactly the same. So both methods will get you to the answer, but I do find that method 2 is a little more efficient. Okay, so I'm going to highlight these for you. Here is method 2, and we'll separate it. And here is method 1. And we'll highlight that in blue. All right. And we will just separate this here as well. so there's no confusion. All right. All of this will go up on your notes so that you can follow it clearly. Here, for example number 6, we'd be doing the same thing we did for example 5, except for we obviously have to find our own points. We obviously have a y-intercept right here, but this y-intercept is a hard point to read, so we really wouldn't choose this as one of our points. What we would do is choose this point right here, which is point 1, comma 2, and we might pick another point that's easy to read, like this point right here, which is point 3, comma 4, and we would pick one of the methods from that we just talked about, method 1 under method 2, to then be able to write the equation for this exponential function. Okay, my preference would be method 2. All right, message me if you would like to see how to do number 6, although I think that you should be able to follow the steps as presented. Again, I hope this is helpful as I had time to go over it a little more slowly, and hopefully that was helpful to you. And as always, I encourage you to watch the linked videos. So find the linked video for example 5 in the reading and the linked video for example 4 and example 2, and watch those. They should be of assistance to you as you try to accomplish the homework. Thank you, and have a good evening.